Hello and welcome back to another episode of From the Field, and do we have a good one today? We got our guests from Consigna, as you might have seen them in earlier streams throughout the year. We got James and Quinton here. I'll let them do their little own introduction later on. Just really like Windows Failover clustering, I had never really heard of it before, which is quite interesting because I've been dealing in the whole Windows stack for a very long time now. So, it's going to be quite interesting to hear about the common use cases for it. And, how do you actually handle these legacy structures and processes inside AWS? And, just to actually get that requirements from our customers that we meet in the field that always like to throw a hurdle in our direction. Yeah, definitely. Like that's generally what makes this job interesting in IT, is because you're never entirely sure what dragons lay beneath the discovery. So I'll hand over to James to do a quick introduction to himself, and then also Quinton after that.
Thanks, Casey. Hi, my name's James Corrin. I'm the practice manager of the engineering practice here at Consigna in New Zealand. Today, in a few minutes, I'll be handing over to Quinton, who's going to take us through what a Windows failover cluster is and what it looks like in AWS. If you're familiar with on-premise data centers and Windows workloads, especially in large enterprises environments, you're probably very familiar with what we're about to show you. But what you might not be familiar with is it running in a cloud environment like AWS, which does require a little bit of back-end wizardry to get it all working correctly. On that note, I'll hand it over to Quinton Long. Thank you, Quinton.
Cheers, James.
Do you want to do a quick introduction, Quinton?
Yep.
I just bring up your slides.
Will. Yep. So, name's Quinton Long. I am a distinguished engineer at Consigna. Pretty much mostly have a Windows server background, AWS networking, and security. So puts me in a good position to pretty much play with this stuff every single day.
Awesome, and I'll just bring up your slides here. And before we start, if you have any questions, it doesn't matter if it's actually related to just failover clustering or not, just feel free to ask. As it's not very often you get free experts like ourselves on the stream that is easily accessible. I'm quite happy to go on a tangent. Don't need to worry about it. Just if you have any questions, just throw it our way. Anyway, Quinton, let's crack on.
Cheers, Casey. Okay, so Windows server failover clustering. It's something of a niche, technology when used in AWS. As James alluded to, on-premise, this has been around forever. Now that the New Zealand government is mandating that there's a cloud-first approach to new workloads, and pretty much it's meaning that we're seeing a lot of migrations now. So pretty much data center exit size migrations. As a result of this, we're seeing a lot of workloads that cannot be migrated, with more modern technologies likes of Lambda and containerization. Some of these things still need to run in AWS as if they did in the on-prem data center. A lot of these things have gone away, which is great. The likes of Exchange Server and SQL Server, which were two of the most common things run on a Windows failover cluster. The likes of Exchange Online and SQL Server, always on availability groups, took over that. But there are still some things that we can't re-architect with a newer technology. And a lot of those I see in health, where I've spent a fair amount of time doing data center migrations. The applications, for some reason, just will not run any other way. And I'll kind of go into some of those details in the following slides. So
And also adding a little bit more flavor to that, as we see the regions and stuff come into play, like across all covers, and in 2024 for the AWS region in Auckland, these migrations, and especially with legacy and apps, are going to become much more in play for us IT professionals. So it's quite timely.
Oh, very much so. We're just seeing, ahead of the local zone in the new region, the amount of people engaging us for these migrations is just taking off. Makes us happy, and the customer gets a better result. So the reason we are looking at failover clustering, there's a few reasons, but the most common one that we see is the vendor of the application specifies that the application has to run on a Windows Server failover cluster. If we deployed it in a more cloud agnostic way, it means that the application would no longer be supported by the vendor. In health, anyway, I can talk to this because it's been a bit of time there. This is a major. If an application doesn't run, somebody could possibly die as a result. So going off wild west and deploying something that isn't supported by the vendor, it's not ideal. On-premise failover clusters have a concept of a floating IP address. And this is something that is used a lot on-premise. A lot of the devices used in a hospital or in manufacturing plants, whatever, do not have a concept of DNS. They have hard-coded IP addresses, and they still have a requirement for highly available server infrastructure in the back end. This pretty much means that a lot of the ways we would deploy things in AWS aren't going to work well. And as such, we had to look at a way to make a Windows failover cluster in AWS work very similar to what they were accustomed to on-prem. So things that we've actually used this for, so this isn't just a hypothetical. So we've actually deployed these and they're running well. No one's had any issues. Currently, we've got this running for a migration of HL7 messaging at a hospital, and also the bedside high acuity monitors. So it ticks all boxes. It's highly available, it's reliable, and it meets the vendor's requirements. So for this demo that we've put together, we have tried to do this with everything that is native in AWS. We haven't gone out of the way to construct something that you couldn't just easily spin up, either through the console or the CLI. So obviously for a Windows failover cluster, we needed some EC2 instances. In this instance, we've got a 2-node cluster, so we've got 2 EC2 instances running. We have a third server running, and this is a bastion, so we can manage the Active Directory. We can add users, change permissions, whatever we need to do there. We're running 2 flavors of FSX. The first one is FSX for Windows File Server, and that provides us with a couple of things. The first one, with regards to cluster, is it gives us a file share witness. So we don't need a third node as the witness to the cluster. We can use a file share. The other reasoning behind this is it gives us nice, easy Windows file share that we can use anywhere else in the business without having to build and manage file servers. The other one is FSX NetApp on tap. So this is set up so we can present shared cluster storage to the cluster. So if we have a failover, pretty much it's like bringing the state with the server. So the application writes something to the disk, it fails over, that is still available. It also has the benefit of only one node can write to that storage at any one time. So you don't get a split brain kind of thing or locked files. We've also built in AWS Managed Active Directory. And the reasoning behind this is we needed something so we could do a domain join and set up the permissions for the cluster. Most of the time, I'd say 99.9% of the time, anyone like going down into the the Microsoft server, the clustering already has on-prem Active Directory. So either reach back across VPN Direct Connect to contact the Active Directory, or better approach is bring your Active Directory via migration into AWS. Everything's closed, works well. The last thing that we had to put in for this is IAM role for our instances so they can act on our behalf to make API calls. So just a quick overview of what we've actually put in here. As you can see, we've got our 3 EC2 instances. The top one, node 1 of our cluster. If you look down the bottom right corner of that screen, you'll see there are 2 secondary IP addresses. The first one is its cluster IP address that we use in the clustering setup. The second one is a floating IP address. And that is so we can flip this one address between the 2 cluster nodes to provide that floating IP similar to what we have with our on-premise failover cluster. We also have the 2 FSX file systems. Explained a little bit about these before. The NetApp on tap, not something that I've actually used prior to setting up these clusters. I was amazed. The documentation provided by AWS, it's fantastic. They had demos. You could look online, see a YouTube video of how to do it. The documentation was good. It just kind of worked out of the box. Highly recommend it.
And the FSX was mainly used for the shared state between the cluster. Is that correct?
It was. So yeah, it provides. So we can set up a iSCSI target there. The Windows server can manage that quite happily.
Awesome.
We had a few options of storage. it was by far the easiest and the slickest. The managed Active Directory, pretty straightforward. This was pretty much straight out of the box. Very, very little configuration required. It was just done through the console. We actually did this through CloudFormation. So pretty much end-to-end, this build was only a few hours, which was good. It meant we could spin these up, spin these down, try things. It was cheap, it was fast, and it meant a few of us could have a crack at this at the same time. So it was also a learning experience for us.
It's also worth to note, but before you continue on, that generally any enterprise that have these issues or these type of systems will have what I call full fat AD, which is generally a AD that they've set up on site, on-prem AD. And really, the managed AD, what is good, is generally better suited for small to medium businesses due to the fact that it has a lot of limitations around it, like such as the fact you don't get full admin into the AD. So it makes it harder to extend domains and all of that good stuff that generally an enterprise level business would be wanting. But for a demo or for proof of concepts, the managed AD service makes it very easy to get an AD up and running like really, really quickly, as Quinton mentioned.
Yeah, it sure did. It's like we like it. Okay, next thing. So to enable our two cluster nodes to be able to talk back to AWS, request a change in its IP address, so moving the IP addresses between the nodes, we needed to update our IAM role. We already had one attached to the instances, so we could use SSM, so the Fleet Manager, to RDP effectively onto these machines. So this little snippet we added, which just allows reallocation of the IP address for two network interfaces. We didn't want to go too broad because we didn't want someone jumping on these servers and messing with anybody else's IP addresses.
Least access is definitely something that you want to strive towards. It's a bit of a pain to get and lock down those IAM roles, but it goes a long way to your security footprint.
It does. Totally recommend it. And you're right, it can be a challenge sometimes. CloudTrail is your friend.
Yep. And there's a couple tools out there, like I think there's IAM Live, which is on GitHub, what gives you a really good starting platform. It's not perfect and it is a little bit open in itself, but it does give a really, really good starting platform. And also if you use services like the CDK as like your way of developing, or Terraform, then they also have inbuilt mechanisms to help scope those IAM roles appropriately.
Cool. Cheers, Casey. After the build, we end up with what anyone that's been in the space before, dealt with clusters, this will look very familiar. For those that haven't, the things of interest are the cluster core resources down the bottom here. The most important one is the cluster shows online, and the witness shows online. James will go through this in more depth when we do the demo. You can crack this open and go down through the options. And now the bit that probably everyone was actually wanting to see. We'll start with 2-node failover cluster and a single AZ first. So this is the one that we commonly use when a floating IP address is required. As a lot of you are probably aware, there isn't a way to stretch a subnet across multiple availability zones. So if we want to take an IP address and move it between nodes, it has to be in the same availability zone and in the same subnet. Underneath the two failover nodes, we have got the two FSX file systems. They're just built into the same subnets. They are highly available, so they do span both availability zones. And likewise with the managed Active Directory, placed in its own private subnet and replicated to second availability zone, all with a click of a button. We didn't have to manage anything. The only other thing in this diagram is up here in the top right, which is our bastion, which is used for managing Active Directory, and also gives us a view into these two failover clusters. So we can do like name server lookups and just check that the stuff is working. So this is slightly a more traditional looking architecture. We're actually taking the cluster across multiple availability zones. With this, we have an issue, namely that the IP address can only flip between the two cluster nodes in one availability zone. The third one is pretty much out on its own. Good news is for any customer that is not tied to requiring the floating IP address, namely that they can use DNS name for the cluster, this will work across multiple AZs. So the cluster itself has the ability to update DNS. So whichever node is live will update DNS to the live node's IP address. So if you're using DNS, multi-AZ, failover cluster, awesome. The way this one is architected, so in this diagram, it's kind of a hybrid of both. So this is actually something we have set up for a customer and are currently using. The idea behind this is they do need to use a floating IP address. So normal operation is the two nodes in the left-hand side of this diagram and one availability zone. Normal operation is if they need to patch something or if there's a failure on the servers, it switches to the other server in the same availability zone, the IP address comes across, everything continues to work like normal. The idea behind extending this out to the second availability zone with a third node is in the unlikely event of an AZ outage, they still have something there. There will be some reconfiguration required for the likes of their firewalls, because the firewall VIP will need to be repointed to another machine, or the hardware devices that have the hard-coded IP address will need to be updated.
From your experience, Quentin, do a lot of these systems that require this type of architecture, are they like a new script against them to actually make this update a lot less painful for the person making it?
I would love to say yes. It is normally someone rocking up to a hardware device and actually punching numbers in.
It's very much in-person deployment, which is exciting when you have probably like 20 locations around New Zealand.
Luckily with the health stuff, it's contained within the hospital, but you'll find that the same devices are deployed in every single ward. So it's all hands on deck, people running around making physical changes.
And also in hospitals, actually finding an asset is a mission, because I know from the stories I've overheard, like we'll talk to my friends, stuff that nurses will quite often hide things so they know where it is when they need it. Yeah, and so others can nick it. So yeah, it always has those exciting times as well, where the processes meet real life and it makes things a lot more difficult.
It does. Luckily, outages in AWS don't last very long, and probably before we got people mobilized to make these changes, it would have been fixed. But it gives an option. So this design was pretty much done to meet the customer's RTO. They couldn't wait for long enough for it to be rebuilt from an AMI or can't remember how they did it. Yep, I think it was an AMI and manual configuration for a lot of this. So that would take a lot longer than just reconfiguring the devices, which would need to have been done if they rebuilt another AZ anyway.
And this also handles the edge case that machines and devices do fail. Like if the underlying hard drive fails or the host needs to be like retired, then actually having this like even in the same AZ gives you the ability to handle that the future and actually quickly recover, as you mentioned, as we'll see in the demo, just quickly change the IP to the healthy host, which is massive because that stuff does happen and
you're right,
to take for it.
Yep. And the most common case we see is patching. In a cluster, it gives them the ability to patch the offline node and then do a graceful switch over without having to pretty much make any other changes.
Being able to test it live, patching as well, that's always a huge boon. I've had patching brick my servers before. I would, 1 out of 10, would not want to do again.
Yep. I think we've all been there. Okay, and now this one is over to James.
Sweet. Let me just switch the screens around. There you go, James. You are now good to go.
Cool. Thanks, guys. So as Quinton explained earlier, we've got 3 nodes here deployed into our AWS region here. Obviously, there's only 2 nodes in our cluster because what we will be demonstrating today is the failover of the not the elastic IP, the floating IP address, which you can see here. So each node has a secondary IP address that we use for the cluster configuration, but only one of the nodes contained the floating IP address. And what you'll see in this demo is this IP address should flick across to here, meaning that that IP is continuously up no matter what the backend node is doing. AD administration, this will just be our server. We're observing that change from just a out of the way thing. Think of this as a on-premise device or something like that that Quinton may have alluded to earlier at a hospital. So let's switch over to Fleet Manager here, and you can see I have already logged into my servers. We have the AD administration, which is the one I just talked about, that we'll be observing the change from, and we have our 2 nodes here. We go into node 2 and just open up Windows Failover Cluster Manager.
Let me make this a little bit bigger for people as well.
Yeah, sorry, I'm not sure how to do that from my side, so hopefully everyone can see, but if not, I'll try and explain what I'm showing you here. So yeah, as you can see, we're in Windows Failover Cluster Manager. We've got our cluster here with a nice name here that's joined to our wfc.consigna.cloud domain. The cluster's name is cluster originally. What we got here is, as Quinton pointed out before, we have our resources here, and if we just expand the actual cluster resource here, you'll see the 2 IP addresses assigned to the different nodes, and one of them is online in an active state, which is the current host server, which is node 1, so not the server, and then we have our offline server, which is actually this one that we're looking at here, node 2. So this is, well, it says offline, but really it's in a standby state ready for an incident or anything to happen on node 1. So what we're going to do is we're going to do, as Quinton said, we're going to do a graceful failover. And yeah, as Quinton alluded to earlier, like you would probably do this for like patching, or if you just wanted to free up some load on a particular node. That rhymes, guys. Right, so we're going to do that now, and we can just do that by right-clicking the cluster, more actions, move cluster resources, select node, and I'm going to choose node 2. And hopefully you guys can see this at home, but you can see that the cluster's gone offline temporarily, and boom, flicked it back on online. Our node 2 IP address is now the one that's online, and node 1 is no longer online. And we can see up the top here, we've got our cluster name and we've got our node 2 as the current server. And what I should have done is demonstrated with an NS lookup prior to doing that. But that's okay, we can do that now. So do NS lookup on the cluster itself. So that was cluster.wc.consigna.cloud. That will return straight away the IP address .61, which is the node 2 secondary IP address. Cool. What am I forgetting? I am forgetting, with that change, we should have had the floating IP address I mentioned earlier should have migrated from node 1 as well to node 2. So if we needed to rely on a static IP and not just that DNS name moving, we would see that that IP has now moved. So as you can see, the .100 address is no longer a secondary IP address on node 1. It is now on node 2. Magic. So that changeover is not instantaneous. Unfortunately, it is pretty quick though. It's less than a minute. In fact, it's about 30 seconds to switch over, which, in an event, in an outage for something like an application is not too bad, to be honest. It's pretty good.
And for legacy applications, a 30-second downtime if something happens is a very significant improvement to what they would be used to. So generally winning all around.
Exactly, yeah. The only scenarios where this might not be good is as some of the applications that Quinton also said earlier, like SQL clusters or Exchange clusters, but there's already better solutions out there for those products. So this is purely for your legacy applications that typically don't really require these, they require high uptimes, but a 30-second outage is not going to have anyone's head on a pike. Cool. So that was a graceful failover. Let's one of the things that Casey brought up earlier is, failures happen all the time, right? Back-end hardware could crap out, and nodes could go down instantaneously without anyone realizing. What I'm about to demonstrate now is we're going to simulate a live failover by shutting off one of these nodes. Now, node 2 being the primary node at the moment, I think it'd probably be a good idea if I choose that one. Right, guys?
Yeah, kill it.
Cool.
Yep,
right.
make it happen.
Let's do it, eh? So this is node 2 here. We should see this disconnect when I kill this. And we will see, I'll connect onto node 1 and we will see all the magic happen from there. So instant state, terminate? No, not that one. We'll just stop the node today.
Yeah, look at you. You're only doing half measures. They're terminating the node completely.
That's right. But hey, if you've got your intern and you ask them to terminate a server and they accidentally choose the wrong server, if they choose the wrong server that happens to be in a failover node, it's not going to be the end of the world. So this is another possible cause of why a failover cluster is a good idea.
If the intern has access to your production AWS account, I got words for you, and we can have a chat about that offline.
That's right. Cool. All right. So as I mentioned before, we've lost the connection to node 2. So let's go on to node 1 and have a little look-see here. Probably should have had this open so you can almost see it in real time, but it's only been a minute or two. So if we go here, so it has detected that one of the nodes is down, which is good. And is the cluster still online? Yes, the cluster is still in an online state, which means it will be presenting whatever application or service it needs to still. And you can see here that we're back to the original IP address of node 1. Now let's double check and see if the secondary IP address has migrated across. So first we'll have a look at node 2 and just see that the secondary IP address is no longer there, the .100. Yep, that is appeared to be gone. And if we have a look here, yep, .100. Excellent. So that's exactly what was meant to happen. The floating IP address has migrated from node 2 to node 1. And I just want to point out as well, if you're familiar with doing this type of thing on-premise, this probably doesn't look that impressive. But in AWS need to be aware of the IP addresses you're using, and they need to be, and this needs to be at the AWS level. So you need something to interact with the AWS API to actually hand over these IP addresses between the two, which is not something you typically need on a flat on-premise network. Cool. So that was a live demonstration of failover. What we'll do as well, we'll do another NS lookup just to see the DNS failover as well.
While you're doing that, you mentioned that you need to give the AD cluster essentially a little bit more knowledge of how to interact with AWS. So other than the IAM policy, is there any custom code you need to supply to get it to know how to switch over the IPs?
Yep, and I'll cover that in a second. And I'll just point out here that yes, with our the DNS failover has worked, and we're back to the Node 1 secondary IP address. But yes, to answer your question, yes, you will need some type of custom script or process to interact with the AWS APIs. You need something to monitor the effectively the node the node states and flick that IP address over as appropriate. This can be done a number of different ways, and just a quick Google, you'll be able to see a couple of different methods out there on how that's done.
So how did you do it? Asking the hard questions.
Yeah, we've got a setup. We've got a custom script on the operating system that is monitoring for events, and it, as soon as it sees those events, it runs the just the standard, the PowerShell tools for AWS command to reallocate the IP address between the nodes. Just as simple as that, really. I'm not going to go into that because I haven't prepared for that, but it's just custom bit of code there that does that for us.
It's fair enough. I thought I'd just put you on the spot and get to explain stuff more. Okay, is that all from you, James?
Yes, I think so. I think, just to point out as well, obviously we mentioned before that an IAM role permission is needed to allow that communication between the operating system and the AWS APIs, so that that IAM policy that you saw earlier on the screen is attached to this IAM role you see here. And that's what allows that. Otherwise, AWS would reject the API call because it's not authenticated. But through this role and that policy, it allows that my IP address to be interacted with from an operating system level.
Awesome.
Cool.
I'll flick over back to Quinton's.
Cool. Okay, so now you've seen it, we can kind of go through the things that, from actually being out in the field, doing this for real, dealing with our customers, the things that we've learned. And some of these will make sense to people that have done this before. I guess the biggest learning that we've got is we have to get buy-in from the software vendor before we start the build. They'll often have a way that they want things configured, and quite often it's hard to roll back something you've built to meet their requirements. And a lot of this is around either licensing. Most of the time it's around support. The other discussion we now have pretty much as soon as we walk in the door and the word failover cluster comes up, is we need to know whether their devices are connecting to the cluster require a floating IP address, like a lot of the old legacy devices, or whether they can use DNS. That will change how the architecture is going to look. If they can use DNS, fantastic. We can do proper multi-AZ. I think they'll get a better outcome. Things are just easier, less moving parts. Less moving parts is easier to support, more happy people. And for the people that run this on-prem, they quite often get sub-millisecond failovers. It's all done in hardware with SANs, and it was built for this. As you've seen through our demo, it's about a 30-second switch over at worst. If you do it through DNS, it'll be a wee bit quicker, but the reallocation of that IP address takes a wee while. when we first were engaged to build a cluster in AWS, we had a couple of options for the shared storage. So we had multi-attach EBS, which at the time just seemed really weird, but it works. It allows you to attach, one EBS volume to multiple EC2 instances. The other option we had was the NetApp on tap, and we went with that approach because it was true multi-AZ. So obviously in EBS volume is pinned to an availability zone, can't stretch it across multiple, but the NetApp on tap, the iSCSI interface presented worked across as many AZs as we had in our cluster. And I think, as James pointed out, the scripts that we used for doing the IP address switchover, easily found on the internet if you want more detail on that. And you can always come to Consigna if you want to talk more about this.
Or reach out to your friendly account SA if you know who they are. If you don't, then it's pretty easy for us to get in contact with us. If you just fill out the contact us form, then someone from the AWS team will reach out to you and we'll start the whole process. But yeah, our partners are definitely people that an entity we lean on as well. I work quite closely with Consigna and a couple of my accounts. So yeah, definitely a good place to start as well. And I see that on the screen you have a lovely roles open. So we are based in New Zealand, the lovely green country of New Zealand, and we are always on the lookout to bring lovely individuals like yourself, if you're looking from Australia or the US or anywhere else around the world, to definitely come over here and look at what jobs are available, because we are in desperate need of cloud engineers and cloud skills. And while we just posted in the chat a link to the AWS New Zealand technical community, which if you are also, again, looking for roles or someone to, give you a accurate lay of the land, yeah, reach out in that group, ask to join, and yeah, that's a good place to start. James or Quentin, do you want to cover anything over your roles above before I jump into the training side of things?
No, I think you covered it all, Casey. But yeah, just open invitation to anyone overseas. Come join us in lovely New Zealand. We're always excited to work with new people. So it would be great to see or hear from you.
Yeah. Our borders are open now, which is great. It took a long time, but we finally got there. So that always helps. And the other one is, if you are looking to, continue upgrading your skills, and also just continue watching us if you want to find these more niche, real world ways that you wouldn't typically be expected to use AWS, but it always comes in handy to have it in your tool bag. Because I sure was, I didn't know about this, was it Windows Failover clustering in AWS? So just added that to my reply. But we do have the skillbuilder.aws, which you can go to. It's a free website. You can say, this is my job role, or I want to learn about this particular topic, such as data analytics or machine learning. And then it will build out a curriculum that you can go through at your own pace as you just upskill yourself and bring on that journey. And a certification, if you want to do that, then yeah, there is definitely a great place to start as well, because it's it's a way that you can prove to an employer, especially if you're a junior, that you are competent in AWS. And as I mentioned before, the skill set for a cloud engineer is in very high demand. And if you have that certificate saying, yes, I do know what I'm talking about, then it puts you in a very good position, to ask for the moolah, which everyone always likes, because no one dislikes money. But I will leave it there. Thank you, James and Quentin, for coming onto the stream today and sharing your knowledge. I really appreciate it. And just goes to show that, that relationship between AWS and Consigna is always going strong.
Cheers, Casey. Been
Awesome. Thanks, Casey. Thanks for your time.
And everyone that's watching the stream, do enjoy the rest of your night or afternoon or morning, depending where on the globe you're watching this. And yeah, as I said, if you do want to learn more, or just feel free to reach out to myself over the LinkedIn or through the contact us form. But Marty wa. Oh, I guess it's